Yeah, very good morning to all of you. So, in the previous class, we have seen up to how padding is being happening for SHA. It has been seen by us in the previous class. So here, as per the high-level picture, which is being stipulated for SHA, secured hashing algorithm, it seems like this. So here, data will be taken into consideration. The data will be called as X, and X will be divided into many number of pieces, and each piece will be 438 bits. Remaining 64 bits will be the size of this particular, how many number of bits are there within this particular, so actual bits are there within this particular area. If a number of bits are not equal to 438, then it is going to pad 1 followed by several number of zeros. So based on to fulfill 438 here. Okay. Likewise, so this particular padding is being happening. After this padding, compression function is going to apply on that particular data, and this particular operation will be took for several number of times until how many number of pieces are there. Pieces are 438 bit pieces are there in our data. Those many times it is going to take, it is going to iterate for number of times. If 5 pieces are there, 5 times it is being iterated. 10 pieces are there, 10 times it is being iterated, and so on and so forth. Finally, it will becomes the final hash value to perform the operation here. Basically, each x1, x2, x3, each piece of this x1, x2, x3 will be 512 bits. And then after padding also, so it is not actually 512, it is 438 only. After padding, it will be converted to 512. If you refer any textbook, it could be seen in the same way. So that is why I have given 512 here. So after padding, it has been converted from 438 to 512, and 512 will be sent to the compression function, and compression function will be reiterated for number of times based on the pieces of your X actual plain text here. Okay, like this, this particular high-level operation is being done here, and it has been already seen this one. This everything has been seen to you. I mean, discussed with you in the previous class. So K will be, the K will be identified how many number of bits you are supposed to add it to the, probably this is 448, sorry, this is 448, not 48, 448. So 512 minus 64 minus 1 minus L, where L will be the number of zeros which are going to be placed into the specific piece of the plain text here. So 448 minus L plus 1 modulus 512 will be taken. These many number of zeros are going to be placed over there. And how these zeros will be placed here in the sense, this is actually your message, 448 bits of message. So if message will be less than 448, you may be append 1 followed by several number of zeros based on the formula, and followed by length of that particular, how many number of actual plain text bits are there, that is being maintained here. So here it could be this operation could be called as a padding. Sometimes 1 followed by zeros could not be there, sometimes it will be there. Okay, and here this is number of bits will be L, and this is K plus 1 number of bits. So K zeros and plus 1. So that is what the point here we need to understand. And this is 64 bits, which is always counts how many number of actual data bits are available within this particular message. So this whole thing will be your actual bit pattern, what exactly what we're supposed to take for each round. Okay, of course it is already seen by us. For example, ABC will be the actual text, and A will be, ABC will be in terms of 8-bit ASCII mode characters. So A will be represented, so 97 will be represented something like this, 98 and 99 will be represented in this following format. Therefore, L will be equal to 8 3s are 24 bits are available. Then how could you add 1 followed by how many number of zeros you are supposed to add? So you are supposed to add k will be equal to, so when append 1 plus followed by k, 423 zeros are supposed to be added. How this could be like this in the sense 448 minus L plus 1. So L equal to, so 24 bits and the plus 1, that is 25. 448 minus 25 will be 423. 423 zeros are supposed to be so added here. And these are as much as many number of 423 zeros here. These are 423 zeros could be added. And this bit pattern is 64 bits. So this is 64 bits. How many number of actual data bits are available here? It is so 24 bits are available. So if you convert this particular data in terms of from binary to decimal, so it will be leads you so 24. So like this, it is going to be identified. Up to this moment, we have learned something in our previous class. Now, coming to how the point will be, we would like to know something about what exactly been happening within this particular compression function. What exactly been happening within this particular compression function? That is our today's agenda. We'll finish off. Okay, look at this. So after padding, it could be divided into compression function will be always need to take 512 bit blocks. Already we have taken. The padding will be always taken 512 bit blocks, and it could be names as so x1, x2, x3, x4, and so on and so forth. And again, this 512 bit block is being divided into 16 words. Each word will be having 32 bits. Each word will be having 32 bits. These 32 bits will be considered as for ith block. So these 32 bits will be, each 32 bit will be considered as one particular block here. So ith block of message of x will be split into something like this. So x will be equal to xi, for example, first block of message. Let me consider, so x1 will be taken into consideration. How this could be considered here, how this could be split into blocks here in the sense, xi of 0, xi of x1 of 0, x1 of 1, and so on and so forth, x1 of 15. So totally 16 words. It is going to divide the total data into 16 words, something like this. Okay, something like this. Okay. And as I just before I showed you something like this, before this compression function, before this particular compression function, so it has been taken, so some iteration, something like this. Before going to take this particular iteration, we have taken some h0. So it is the initial value which is going to submitted here. Is there on in our diagram in the just previous slide. So that h0 is a constant value. It is a constant value, and this constant value could be operated or evaluated by the designers. That constant value has been given something like this. So this one, h0 power 0 equal to this value. B will be considered as h0 power 1 will be equal to this one. C will be so something like this. D will be something like this, and E will be something like this. So which is always we have to consider this is 32 bits. So this is 32 bit, 32 bit plus 32 bits plus 32 bits, totally 532 bits will be equal to 160 bits. Because the output from this particular hash function will be 160, and here whatever the next iteration which could be taken, here also we have submitted 160 only. So therefore h0 value should also be equal to 160. So that is why we have taken as 160 bits, and 160 bits will be divided into 5 blocks. So each block might be having 32 bits. Each block might be having 32 bits. This is a constant value for every time before going to take the first iteration. It is going to be applied or supplied to the specific compression function of SHA. And SHA will be divided into 4 partitions or 4 stages. It has been divided into 4 stages. At each stage, so there might be operating some extra word W0 to W79. So already we told that so SHA will be taken 80 rounds. Okay, so 80 rounds. At each stage, it is going to operate at 20 rounds. First stage 20 rounds, second stage 20 round, third stage 20 round, and fourth stage will also taken as 20 round. So totally 420s are 80 rounds. And these words are divided into, so in such a fashion, W0 to, so W19 will be the first round. So let me show you. While writing all those things, let me show you here. So your message, whatever the message you have to consider here, that particular message will be scheduled. Previously, as far as your Feastal network, let us consider DES or AES. Let us consider this is DES or AES here. This particular DES or AES will be taken, so as much as many number of rounds here. For example, this is round 1, this is round 2, this is round 3. However, whatever it may be. So for this particular round, one thing is the data actual message which is going to be submitted for creating ciphertext here. And the second input will be, input number 2 will be, so key here. So we have been submitted 64-bit key in DES. The 64-bit key will be processed with parity dropper and will be converted into 56-bit key. And this 56-bit key will be again so converted into, so 28 plus 46 bits. Okay, 48 bits. 48 bits. It has been converted, and this 48 bit is going to be sub key is going to be submitted here, and again one more sub key will be submitted here, and again one more sub key is submitted here, and so on and so forth. In DES or AES, based on the number of rounds, so separate sub key is going to be submitted for each and every round. Whereas in SHA, in DES, we have been submitted the sub keys as external parameter for the round here. Whereas in SHA, so you have been submitted message instead of key, because key doesn't make any sense here. Your message will be divided into 80 pieces. So these 80 pieces are going to be divided further into, so 20, 20, 20. For first 20 will be at stage 1, second 20 will be at stage 2, third 20 will be at stage 3, fourth 20 will be at stage 4 here. Like this, it has been submitted, and this particular operation is going to be done here. As I said just before, initially you have been considered one what you call a constant value, which is H0, and H0 was divided into, so 5 different types of blocks. Each block is having 32 bits. So A, B, C, D, and E. You please consider here A, B, C, D, and E. Each and every, so A, B, C, D is a particular constant, and this constant must be, this particular constant must be 32-bit words. Sorry, 32-bit words, yes. Okay, and it has been submitted, and here, whatever the message you have been passed here, that particular message will be compressed by using individual functions K, F1 and K1 at stage 1, F2 and K2 at stage 2, F3 and K3 at stage 3, F4 and K4 at stage 4. Okay, so each and every time the message will be scrambled, otherwise mixed with 2 different types of functions, F1, K1, F2, K2, F3, K3, F4, K4. All these functions are so one and all is individual. They are not supposed to be matched in each way. So for the first round, it has been regenerated ABCD in other format. Second round also same. And at fourth round, after completion of fourth round, whatever the outputs of fourth round will be exclusive ORed with H0 values, and can be finally produce the, so whatever the hash value you are expected. That hash value is being so produced here. So let me show you how the things are being taken into consideration here. Let me show you. So this is the specification which is being happened here. So each block is being so processed for 20 rounds, or each stage will be processed with 20 rounds, and so each internal block or internal stage P is being operated with f of t and k of t. F of t in the sense where t will be ranges between 1 to 4. F of 1, k of 1 is first stage. F of 2, k of 2 is second stage, and so on and so forth. Okay, and then message will be scheduled with 32-bit word as W0 to W79, W0 to W79 for 80 rounds. Okay, out of these, it has been submitted something like this. The words WJ is arrived from 52-bit message, something like this. It could be taken something like this. Okay, this is the formula where exactly you need to consider. So x of I over j will be the round value, stage value. Stage value. If j will be in between, so 0 to 15, in between 0 to 15, it could be taken the x value as it is. There is no combination, or there is no scrambling. Whereas if you are supposed to take 16 to 79, the stage value will be 16 to 79. The word value, which is 16 to 79, you have been operate this particular exclusive OR operation. So something like this. WJ, for example, it is let me consider J will be equal to 16. For example, 16 minus 16 will be taken first block, first 32 bits. That is x of 0 will be taken. So exclusive R of. Then j minus 14. J minus 14 in the sense j will be equal to 16. 16 minus 14 will be x of 2. So x of 2 exclusive R of. I'm talking about only 16th 16th stage. Okay, 16th word. J minus 8, that is x of 8 minus 16 minus 8, 8 exclusive R of j minus 3, that is 16 minus 3, that is x of 13. Okay, this will be considered as W of 16. In this way, W of 16 will be done. W of 17 in the sense, again you have to follow the same. W of 18 in the sense, again you have to follow the same. Like this, so each and every word is being considered and it has been generated. Okay, right away from this particular stage onwards, every time you have been exclusive ORed with x1 to x15, x0 to x15, and you have to obtain W15, W16, W17, W18, and so on and so forth. Like this, you have been taken. After identifying this particular value, what exactly this W16 will be taken. So you please observe this particular thing. So left shift off. 3 times we have been operated left shift here. What does this particular operation does means? So let me explain you. So ROL, rotate left in the sense, normally, so shift left in the sense, so this is most significant bit and this is least significant bit actually. So if you are trying to shift left side, this is the way you have to lift right away from this one. Last and final bit will be vanished. It could not be placed anywhere else. If you are supposed to take only left shift here, so it could not be stored anywhere else. And next bit is being placed here, then bit is being placed here, and so on and so forth. In this way, it is going to placed if you take left left shift here. Whereas if you take this one, this operator indicates you, so rotate left kind of operation. What do you mean by rotate left in the sense, whatever the MSB bit you have with you, so this MSB bit, for example, this is 0 and this is 1, this is 1 and this is 0 in the sense. So while operating this one, exactly for one time you have been operated, this value is going to placed at this place. Okay, and then remaining values. So this could be placed here, this could be placed here, this could be placed here, this could be, and so on and so forth. And the last one, MSB bit value is going to push into LSB location. This is called as so circular rotate or rotate left. You could consider anything, rotate left or circular rotate. So circular queue, you please remember the circular queue. Circular queue is always trying to place the values. So in circular way. So in this way, so it is going to be taken into consideration. That is the meaning of this particular operator here. So after doing this particular thing, finally you could get W of 16, W of 17, W of 18, and so on and so forth. Okay. In this way, you have been acquired the values here. So that is the point you need to identify here. And we came to know, we came to know what is the value of W16, W17, W18, and so on up to W79. Yes, so using this particular formula, you could identify. Then what are the values of F1, K1, F2, K2, F3, K3, and so on? How these values are going to be done here? So that's what I have specified here. The same thing, left shift, circular left shift or rotate left. Okay, rotate left is equivalent to circular left shift. Okay, whatever it may be. Then what are the functions of this particular F1, F2, F3, and K1, K2, K3, and K4? How this could be done here in the sense, this could be done by taking the, not exactly here. Okay, however, HI value will be considered as H0 power 0, H0 power 1. So however, ith location value, H0, H1, H2, H3, H4, something like that, 4 stages are available with us. Stage number 1, stage number 2, stage number 3, and so on. They can be available with us. So this is not important for us. This is very important for us. How you could identify, so F value and W value, sorry, K value. So you could see ABC values are supposed to be identified. So E plus, so this one, E plus, so FT of BCD, FT of BCD, FT will be always so taken into consideration by so A left shift of, I mean circular left shift of 5 times plus WJ. So look at this particular WJ. So followed by B circular left shift of 30 times. B will be circular left shift of 30 times CD. Look at this. A will be directly forwarded to B. A will be directly forwarded to B. And so A will taken into consideration of some other way. B will be left shift of 30 times. Circular left shift of 30 times will be forwarded to C. Okay, look at this. So A will be forwarded directly to E here, and then sorry, E will be taken from A here. E will be taken from A here, and F of T followed by BCD. F of T, the function F of T with the BCD parameters of F of T will be BCD. So will be taken by, so B here. This is actually C, and this is D, and this is this whole thing will be considered as C, and this is D, and this is E. Okay, like this it has been taken into consideration. Okay, and how you could identify the internal functions F of T and S of T, K of T, how the values could be. The values of F of T and K of T will be identified for at each and every stage, something like this. Right away from stage 1, so K1 will be a constant value which is being operated this one. Okay, 5A 82799, and the function F of T will be gets identified. F of 1 BCD will be equal to B and C, or B complement and D. Okay, like this. We know what is the complement. Complement in the sense 1 will be submitted by you, so complementary value will be 0. 0 will be submitted by you, complementary value will be 1. So okay, like this you have been identified for the first stage. Second stage, F2 will be taken something like this, and the constant value will be this one. K2 will be this one, and so this value could be taken like this. And K3 will be like this, and F of 3 will be taken something like this. And K4 will be this one, the constant value, and F of 4 will be so calculated something like this. In this way, so this F1, F2, F3, and F4, and K1, K2, K3, and K4 will be taken into consideration. And finally, you got your output. After fourth stage, you got so A as output here, B as output here, C, D, and E. So these values, whatever the values you got, A, B, C, D values output here, these values is again modulo division with 32-bit will be so taken something like this. So A will be directly modulo division with A of fourth stage output. I mean initial value in the sense H1, H0 values will be directly operated with so modulo division 32-bit. Modulo division in the sense, simply speaking, so exclusive OR operation only. But exclusive OR operation will be gets operated with only 1 bit. So one exclusive OR of so 1 will be equal to 0. But we are not supposed to operate a single bit. We have operated 32 bits at a time. So that is the only difference. 32 bits at a time. That is the only difference. Something like this. After completion of these exclusive OR operations, yes, you could get the output. That is the Shah's hash value. Okay. So this is what the class today. So I will send this particular document to you right now. So right now I will send through Google Classrooms. You please identify and go through this particular document and practice these two diagrams. These two diagrams are very, very important. These two are very, very important. So these two diagrams are very, very important. You please go ahead and try out these. Okay. Thank you.